Hi, this is John Trung here with Proactive Fire Protection Inc. And I'm here with Steve Small with Fire Ready. And today we're going to be at one of our restaurants here in Markham. And we want to be able to explain to you NFPA 96 semi-annual inspection for your kitchen hood suppression system, what it is, why you need to do it, and what it's involved. And I'm going to pass it all to Steve.
Thanks, John. Every restaurant that has commercial cooking has to have a fire suppression system. And like John said, NFPA 96, and in the Ontario Fire Code, it needs to be done every 6 months. So it's something that's required by law for every restaurant to do. And what we're going to do is today we have a commercial kitchen here, and the system is located right in the closet, and we are going to do a full thorough check on it. This is our first time to this location, so we've never been here before. We have a range guard cylinder protecting the cooking environment right here. The cooking environment includes all of the kitchen equipment. So we have a couple of deep fryers, grills, and is protecting this hood with arrangement of these nozzles. One of the first things we do is we turn everything on as they're cooking. We're going to turn on the gas. Okay, the fan is on, and we're going to do a test with using the pull station. When we pull the pull station, we're going to see the gas shut off automatically. There's a local fire bell that we will hear, and the exhaust fan should remain on. And there is an actuator. The intention is this cartridge is going to pressurize the pressure line and activate the actuator. Would normally activate the cylinder, but for the purpose of the test, we'll just do a dry run. Okay, so right now the gas should be off. It's not off, that's a fail. Over here we have the control head has released, the actuator is working, the micro switch released, there is no audible alarm, and the fan is running. So right now there is no audible alarm and the gas remains on, making this right now an automatic fail. This is also an older style pull station that we will look into. The next step is we're going to replace the Fusible link sensors. So we release the slack. There's 6 pieces of equipment. So over each piece of the equipment, there's a detector, which is a Fusible link. And at a certain temperature is designed to discharge once the temperature is met. So the first one is starting over the fryer and the griddle combination. There's no detector over the first fryer, meaning that if there is a fire over the first fryer, by the time it reaches the first detector, the fire could grow exponentially and cause additional damage. So we were going to flag that on our report and recommend to install one over the fryer. So the links are 450 degrees, so we're going to replace it with the same type.
It's important for us to be doing these kinds of inspections for these reasons, because if it wasn't for Steve to test this and making sure that this is actually working, if there was an actual fire, then the system wouldn't operate as per design or how it's supposed to design. So this is why it's so important for us to be able to do these semi-annual inspections to ensure is that the system is going to actually function properly.
And while I'm inside changing the links, I'm also checking all the nozzles and inside the opening of the ducts. And in this case, there's also a lot of grease buildup just inside the plenum area, and these will also be noted that we need to do a proper cleaning service because the grease is a combustible.
And how often, Steve, do we have to clean these filters as well?
So NFPA requires the cleaning to be done at least every 6 months, depending on the use.
Perfect.
Now that we service the Fusible links, we're going to reset the system back before we continue with the rest of the inspection. So now we have our tools. So this system, like most systems, they utilize 3 or 4 stainless steel like bicycle cable. So this cable that travels throughout the entire network of the system is just a 3 or 4 stainless steel. And what happens, because it is a mechanical system, the grease inside of the hood gets sometimes jam the cable because of the heavy grease buildup due to the environment of the kitchen. So now I'm going to set the system. Also, at this time, I'm checking for fraying. This cable, because we're using a turnbuckle and a set screw, it pinches the cable every time this inspection does get done. So this cable will have wear and tear. So this cable is already showing signs of fraying. And when it starts to fray over time, it will cause a weakness in the cable, causing the system to possibly discharge without a fire situation. Okay, so the system is now set. Now we will check the Fusible links that we replaced one by one to ensure they're still holding. So in these sections where the cable travels, there's grease buildup, and what happens during the semi-annual inspection, we exercise the movement. So any grease gets hard will get broken up. Therefore, when it has been some time since the last inspection was done, the cable could get hung up with the grease buildup in the conduit lines, and that may cause the system not to be as effective, or there would cause a delayed response time before it goes off. Okay, so now the inspection of the testing has been done, the links. We're going to now check all the piping and the installation configuration from the system. 34.
Why are you measuring the height there?
So each piece of equipment has a dedicated targeted nozzle protecting it from the manufacturer. So it's been tested that this nozzle installed in this orientation, a certain height over the hazard, will extinguish and suppress the fire over this deep fryer. So we are confirming that the minimal and the maximum heights are met, and the aiming point is achieved as designed by the manufacturer. So this is what I'm checking now. And additionally, inside, because there is a lot of grease buildup inside of the hood, this particular hood poses an additional set of hazards because the duct that goes up, it has an upper plenum, meaning that there's another shaft that goes sideways. So there's additional discharge nozzles placed inside of this opening.
Oh, I see.
If you can see, for range guard, if this riser is over 6 inches, we could just have a nozzle pointing up to it, but because it's only a 4-inch, and the duct opening is beyond that. So we have to climb inside to verify and confirm these nozzles, that they are properly protecting it. And if you could take a look, you can see the grease buildup. So if there is any sparks or if it does catch fire, the grease will carry that flame onto the roof of this building. And for the nozzles, as we open them, we're confirming that the inside screens are clean, and they also have a burst nozzle seal in place. And if they don't, we will disassemble it and ensure that it's fully functional. So the second issue that I've seen is when this hood is a listed hood to contain a fire within the hood capacity. Any penetrations in the hood have to be sealed by an approved ULC listed device. Over here, the pipe that penetrates through the hood, they utilize some kind of caulking. If you come over here from this side, you'll see there's been hood caulk instead of a proper ULC listed hood seal, meaning that this will fail in the event of a fire, and any grease, smoke, fire could propagate through the hood and cause secondary damage, and it will not contain the fire within the hood where the suppression system could extinguish it. The second component here is the detection line. It comes from the suppression system and it goes through the hood, comes back and into the manual pull station, creating this to be the end of line device. So therefore, if there's a problem with the first link, anything beyond that, it will cease to operate because there's been an issue at the beginning of the line. So this type of installation has been now rendered obsolete, and we will have to do a retrofit. We'll have to run a dedicated line for the detection line so the system can automatically activate and suppress it, and a manual line completely separate from the same individual line. So these are our findings so far, so let's keep going. And the flame is still fully on with the gas shutoff valve tripped.
So if you can explain that there, Steve, so that you're saying if the system was actually activated, that means that the system should disconnect the gas, which shuts off the heat source, so it's not going to add more heat to the fire, right?
So right now, when we did the full test, the mechanical gas shutoff shut off this entire line, and it's still on. That means if there was a pot left on or the deep fryer was on fire, the suppression system would discharge, put the fire out, but because the heat source is still on, it would re-flash and the fire would reignite and continue to burn. There's no secondary backup, and once the system has gone off, it doesn't have any additional coverage. And at this point, the fire would just spread. By 21, 23, by 14, 24 by 23, 24, 16. Each appliance has its own dedicated nozzle coverage. Each nozzle does have a capacity of how big of a fire hazard it will protect. So right now we have an ADP nozzle which will protect a 36 by 24 inch griddle. In this case, I'm confirming it's 20 23 by 24. So it's smaller, so this will sufficient for this. This nozzle with the 4 lines, it's an R nozzle, which is different from the ADP, and it's designed for burners. So a 2 burner, a 4 burner range, which will do a 24 inch, and this one is 24 inches. So we're confirming that this nozzle will in fact...
It's actually designed properly for the actual appliance.
So right now, all the nozzle types, placements, and orientations is being confirmed to make sure that if there is a fire situation, this is tested to suppress the fire. And then, once we confirm all the nozzles are correctly placed, we count the flow points. The flow points is a calculation designed. Each nozzle will release a certain amount of chemical agent from that cylinder. So right now, these are all 1 flow point nozzles. So the fryers, there are 2 flow points. So when we add them all up, including the duct and the plenum, we're at 15 flow points. So we need a cylinder that could support that. And in this case, they have a 6-gallon range guard, which could do 18 flow points. So we're covered, we're below that threshold, which is good to have a little bit extra. That way there's more suppressant chemical agent that will go on the fire. Before we start arming the system, we're going to install a new actuation cartridge, 62.6 grams, June 26. Dated, we'll document this on our report that it has a full weight. And I'm also confirming the vent check plug is not blocked in the cylinder, and reset the actuation devices and set the system now back to its design operation. And then we can start putting everything back, and then they could start cooking without any interruptions. All our findings we'll document in our findings report. We did forget to mention the K-class is also essential part of every commercial kitchen. This extinguisher is to be used as a backup for the grease cooking if there is a fire. The first mode of defense is to activate the pull station so the gas could shut off, the suppressant could activate, and then an alarm could go off so that everybody who is eating or dining in the restaurant could evacuate safely. And then this extinguisher could be used to as secondary supplementation to the fire safety. So this cylinder here is dated 2020. They are good for 12 years, so we're still within our 12-year hydrostatic test date. The vent check plug is confirmed to be working. The fittings are tight, so we're going to make a documentation about, let the client know about the fraying of the cable. And this line here, that goes from the A+ control head to the actuator, it needs to be 3 feet minimum. So after we'll make sure that this in fact is 3 feet prior to going to the first actuator. So regular temperature check.
Okay.
So we select the temperature. Right now the cooking is not on, but usually whatever the numbers, we add 70 to it.
Okay.
So let's say it would be 140, and then that's the link we will pick for this equipment. And then if this is closer to the baffle, the heat will not have enough room to dissipate. So if you put a link too low, it could actually discharge the system because they'll just melt it because of the heat. So we need to make sure we're selecting the proper link temperature for the proper application. For example, like McDonald's, they have a lower hood.
Yeah.
So if you put a link too low, what could happen, it could discharge and splash.
Yeah, it will be like an accidental discharge.
That's right. And if there's no fire and there's somebody standing right in front of the fryer, this could splash and potentially cause splash burns, yes.
Gotcha.
So there's a lot that goes into it to make sure that every area is covered. So these filters, they're supposed to be in, and as the air passes through them, they collect the grease to collect in the trough and then go into the drip tray, which could be emptied out. Otherwise, the grease inside will accumulate.
Oh, that is disgusting.
And it will sit in the bottom, and then if this was to ignite, it would just spread all along the hood areas. The suppression system will eventually pick it up through the detection network, but this is where good housekeeping or having a cleaning company would come in handy, and we'll let them know that this is done to be done. So this valve here will fail to operate. So we're going to confirm the size, and it is 1.25 inches. So we'll have to get 1.25 inch valve to replace it and redo the connections. And you can see the grease is dripping from the main floor.
Okay.
There was a bag here to collect it. You never know what you're going to find in these basements. Yeah, so this pull station, so what I was in the videos saying, the system goes into the hood, goes through all the detectors, comes out of the hood right here, comes over, turns into here.
Okay.
So this becomes your end of line. So in the NFPA 96, they found this system to be not operational because if there's a lot of grease buildup in the hood, and then what happens, let's say the conduit is completely clogged up.
Yeah.
So what happens if there's a fire, it will melt the link, but the system, anything beyond after, because it has to go all this way, is not gonna work. So even if I pull this,
Yes.
but there's a lot of grease buildup in the detection line, that's gonna hold it up from before it could communicate it to the system. So then in the newer code, they made it mandatory to either put this pull station in before the hood, so use a T-pulley, so then it goes through the pull and then the hood, or have one line dedicated to just the appliances and one for the pull station, so they did not interfere with one another.